Good afternoon, everyone. My name is Jackie Rapat. I'm the Associate Dean of Research in the College of Rehabilitation Sciences, and I'd like to welcome you to this Illuminate session. The purpose of the Illuminate speaker series is to inspire and incite our constituents to consider ways that rehabilitation science research can enhance the lives of those who we serve. Through the series, we offer an opportunity to exchange information and ideas, internal and external to the college, that advance and enhance knowledge, and an opportunity to develop collaborations and partnerships within and beyond rehabilitation sciences. We've recently reviewed our processes for this series, and in the very near future, we'll have an application form on our recently revised website so that you can nominate future Illuminate speakers along with links to past Illuminate presentations. So now I'm going to ask Dr. Amin Chaku, Assistant Professor in the Department of Occupational Therapy, to introduce today's Illuminate speaker, Dr. Maddahi.
Thank you, Dr. Rapat. Hello, everyone. Please join me in welcoming Dr. Ali Maddahi. He is a postdoctoral fellow in our college. And today he's going to talk about the application of engineering concept and solutions to tele-rehabilitation with the focus on remote hand therapy. Dr. Maddahi, you will get 30 minutes to talk, and then we will get like 15 or 20 minutes for question and answers. For the audience, if you have questions, please feel free to share them in the chat box, and we're going to go through that just after Dr. Maddahi talk. Thank you.
Thank you, Dr. Chaku. Hello, everyone. Thank you for taking time to attend my today's presentation. I am Ali Maddahi, a postdoctoral fellow with the College of Rehabilitation Sciences at the University of Manitoba and the CTO and co-founder of Tactile Robotics, a tech company located in the Smartpark area at the UM. I received my PhD in the field of signal processing and control engineering around 2 years ago. And starting April 2019, I have been a Mitacs accelerate postdoctoral fellow involving with the projects related to the rehabilitation sciences. I aim to realize the academic research results into real applications in a close collaboration between the University of Manitoba and Tactile Robotics. Today, I'm going to talk about the inclusion of robotics, haptics, and Internet of Things technologies in the rehabilitation practice. First, I'm going to give a brief introduction about one of the common diseases that exist all over the world, followed by the statement of the problem caused by this disease and the general solution that exists to solve this problem. Then I will talk about the conventional and technology-based methods that have been developed to help solve this problem, along with some examples of the existing technologies. I will then pose some stumbling blocks for the existing technologies and the use of them from a different perspective, and will explain our proposed solution along with the main features and technical aspects of our platform. Stroke. Stroke is a known word to everyone, and according to World Health Organization, is defined as a syndrome characterized by the sudden onset of the focal or global neurological deficit, lasting more than 24 hours, or because of a lethal outcome. Hopefully, unfortunately, advances in emergency stroke treatment have helped limit the damage to the brain. The damage to the brain occurs either because of bleeding into or around the brain, or from the lack of blood flow to a region where nerve cells are robbed of vital supplies of oxygen and nutrients. Let's take a look at the statistics on the stroke prevalence. For example, in the United States, every year, around 800,000 people suffer a stroke, and around 2/3 of them can survive, which is around 533,000 individuals. And every year in Italy, around 196 cases of stroke occur, of which 80% of new cases and around 20% are relapses affecting previously affected subjects, which is around 40,000 people. As we know, after a stroke, it's estimated that around 20% of cases do not recover the use of upper limb, and most of the subjects undergo a partial recovery. So, loss of functionality in the use of upper limb is one of the main factors affecting disability. And we know that the people who survive the stroke perceive the loss of functionality of the upper limb as one of their major problems. And the impairment in the upper limb is in fact one of the first obstacles to the recovery of the competence in the management of ADL activities. So the main problem caused by the stroke is the loss of functionality, especially in the upper limb part. And there exists several technologies and techniques for treating the upper limb damage by the stroke. Specifically for the upper limb rehab and hand rehab, there are various conventional and technology-based methods that I'm going to talk about. The goal of rehabilitation are to optimize how the person functions after a stroke and the level of independence, as well as to achieve the best possible quality of life. And the rehabilitation helps the patient who has experienced a stroke relearn the skills that are suddenly lost when a part of the brain is damaged. There are various conventional methods for treating the hand rehabilitation. As an example, the mental imagery is one of the conventional methods, which is the conscious representation of an action based on the activation of the motor neurons of the nervous system. And mirror therapy is a method through the observation of a specific movements or tasks performed by the physiotherapist or by unaffected limb reflected in a mirror position at the level of the midline of the body. And functional electrical stimulation and transcutaneous electrical nerve stimulations are used to activate muscles and generate sensory inputs. With respect to the technology-based techniques, the rehabilitation with robotic systems offers patients a high dosage and training intensities, allowing a repetitive practice of the specific movements and functional tasks. The end effector devices, which are also known as haptic interfaces, are the robots consisting of devices to be connected to the end of the robotic arm so that the patients hold the device to interact with the environment. And exoskeletons are used to follow the anatomy of the patient's upper limb, to which they are attached in some points, thus constituting a sort of artificial musculature. There are various kinds of technologies using the robotic and haptic systems all over the world. One of the interesting ones is the wrist robot, which is a 3 degree of freedom exoskeleton, allowing different kinds of movements of the wrist. As another example, Bimanu track, which is a 2 degree of freedom device, allows the patient to perform the pronation, supination, and flexion extension movements when doing the upper limb rehab. One of the most interesting technologies is the no-fake smart gloves that measures the movements of the forearm using some accelerometers, IMU sensors, and bending or flex sensors placed on the finger. And with respect to the haptic gloves, a three-layered, this photo shows a three-layered spring mechanism on a hand exoskeleton with some elastic components serially connected to each other to perform the flexion extension of three joints only using one actuator. So we have seen different kinds of technologies, but considering the existing and available solutions and technologies, there exist some important factors that are affecting the upper limb rehab practice. These factors can be the accessibility rate to the care, the rate of patients' engagement during the rehab practice, the service availability to remote communities, and the qualitative feedback that exists at the moment for the patients and care providers. And last but not least, the COVID-19 pandemic, which has slowed down the rehab practice. So considering these stumbling blocks, we are gonna provide some solutions to tackle these stumbling blocks. As an example for the accessibility to the care, the statistics says that the number of physiotherapists that are available per 100,000 population in Canada, in urban area, is only 68 physiotherapists. While this number is around 41 in the rural areas. And the corresponding numbers for the province of Manitoba is 72 for the urban areas and 28 for the rural areas. Note that 72 and 28 is per 100,000 population, which is a very low number. And with respect to the percentage of the physiotherapists working in the rural area, only 10% of physiotherapists are working in remote communities and rural areas, while this number is only 14% in province of Manitoba. So it shows that the access to physiotherapists and clinicians is very difficult in rural and areas and remote communities. For this purpose, we are improving the rehab process by employing the engineering and computer science knowledge in the rehab practice. Using the robotics and haptics, we have designed a comfortable, easy to use, low cost, and smart and haptic or actuated glove for the patients with upper limb disability. By employing the computer science knowledge, we have provided the patients with the user-friendly mobile applications during the rehab practice. And the Internet of Things has helped us to provide the remote communities and rural areas with the tele-rehab. That will be the focus of the rest of this presentation. And also, we have defined some key performance indices and quantitative measures aiming to let clinicians and care providers receive instantaneous feedbacks in numbers and graphs from the rehab session, and enable them to effectively monitor the patient's improvement over different sessions of the rehabilitation. So, what's upper limb tele-rehab? Upper limb tele-rehab consists of two main sides. The first side is the patient side. The patient is staying home and they don't need to go to the clinic or set any appointment with a clinician or care provider for the rehab practice. They stay home. They have access to mobile applications. They can actually do the rehab task, and the results, the data, and the video are remotely sent and transferred to the care provider in the clinic. The care provider has a kind of desktop application to communicate with the patient. I will explain more in detail about the features of the mobile app and the desktop application that we have developed. For example, in the patient side, the patients are assigned a list of rehabilitation tasks according to their needs. As you can see some examples in the picture as shown, which is showing the screenshot of one page of the mobile app. The patients are presented their own personal rehabs and they can track their daily progress. Also, they are able to opt in for daily reminders for the rehab tasks, meaning that, okay, how many times they are going to repeat the rehab task for their, actually, according to the severity of the impairment that they have. We have also considered some extra features in the mobile app for the patients. For example, each rehab task is introduced with some recorded videos, and the tasks have some kind of written description, so the patients can actually read the description to follow the task properly. And also, the practitioner can set a daily goal for the rehab task for each patient. And also, the important thing is that the patients do not need to set a time or appointment to do the training and the rehab task. At the moment, they have to actually set an appointment to go to the clinics and conduct the rehab task. But using this platform, they can stay home, they can start the training at any time that they wish. As I mentioned, when the patients are doing the rehab task and they are communicating with the clinician and care provider, they can actually see their live video during the training. And there is only one option. They can actually, if they are not willing to see the videos, they can actually opt out the live video from the application. They are also given the live measurements of how good they are performing the rehab task. As shown in the actual photo, we have defined some KPIs: performance, quickness, greatness, and other KPIs, and even how much they are bending the each finger of the hand during the rehab task. So all of this data will come with a kind of report for the after the session is done with for both the patient and the care provider. There is a feature that the clinician and care provider can set a specific time for performance of the rehab task. So the patients cannot stop the training and performance of the task before that defined amount of the time. And also, as I mentioned, the KPIs are graphically shown to the patients after doing the task, which is giving them a kind of quantitative, actually, feedback about their progress. It's not like just hearing that, okay, so you did great, you did good, you need to, for example, practice more, or some qualitative expressions. They are given the numbers and graphs, and they can follow up their progress, which helps them engage during the rehab practice. With respect to the care provider side, they are given a desktop application to communicate with the patient. And the care providers can watch the video of the task performed by the patients in a real-time fashion. And also they can we have a feature to record the video, and the care providers can have access to the video of the task in a later time to watch it if they wish. All training logs and KPIs are also sent to the care provider after the training is done. And this helps the provider to analyze the performance of their patients and try their improvements. This is a screenshot of one of the pages of the desktop application for the care provider. As you can see, the patient's information can be seen on the top, including the name, age, phone number, and other stuff. And the training history aligned with the video of the patient's task, the date, time, and some actually graphical KPIs showing the range of the motion of the fingers for the patient. After each session, the care provider can even modify the program task. For example, after some sessions, they observe that, okay, they need to change the rehab task for this patient based on the improvements that they are seeing. So it's not like this that there are only some predefined tasks. They are able to modify the program task based on their observation. They can also write a message or record a video or leave a voice message to explain the progress and other treatment factors to the patients and communicate with them. And one of the important features of the platform is the scalability of the database, which allows the care provider to send new videos, not only the predefined ones, and updates our database accordingly. To develop this platform, we have, as I mentioned, we have used the different knowledge of using a team of engineers, computer scientists, programmers, software developers, and statisticians. For example, for the mobile app, we have developed a cross-platform mobile app that is can be used by the patients to work with that using under iOS or Android operating system. So the mobile app is available under both operating systems. We have designed a local database so that the patient's data can be sent wirelessly, actually from the sensory system to the mobile app, and the local database helps the patients to actually have access to the results in a later time on the mobile application. We have developed a novel sensory and actuated system in the actually as a smart and actuated glove that measures the motion characteristics when the patients are performing the rehab task. And one state-of-the-art communication protocol has been utilized to wirelessly transfer the data from the sensory system on the glove to the mobile application. We have also developed some custom libraries, which are Tactile Robotics, actually IP, to pair and unpair our sensor in presence of different Wi-Fi networks. So the patients can use this platform anywhere. It's not like it's not like this that they can use this smart glove and the mobile app only under one Wi-Fi network. If, for example, they move from one place to other place with a different Wi-Fi credentials, they can easily pair and unpair the sensory system to the new Wi-Fi system. And also we have a database that is designed on a cloud server and which stores all videos of the task and KPIs. The care provider desktop application is connected to the cloud server, which actually let them monitor the patient's performance remotely. As I mentioned, several KPIs have been introduced, which provide the quantitative measures of the task performed by the patients. And the user-friendly desktop application that we have for the clinicians and care providers to communicate with the patients. The tele-rehab platform that we have designed and developed, actually it facilitates the rehab practice by the patients with no need to be present in the healthcare centers or clinics. They can stay home and actually perform and continue the rehab practice. This platform provides a comfortable accessibility to the rehab care, not only for the patients residing in the main cities, but also for the remote communities and rural areas where actually access to the rehab practice is difficult, and they don't need to move to main cities to actually use the rehab practice. As we know, we are now currently during the pandemics and COVID-19 outbreaks, and the rehab, this platform allows the rehab practice not to stop during the lockdowns and pandemics. And we know that the stop in the procedure of the rehab practice will cause the patients give up, and this platform will help them actually not to give up the rehab procedure, because they are able to use our platform, which is the IoT base, to practice the rehab task. One of the most important features of this platform is that unlike the conventional methods of the rehabilitations that the patients are seen to give up the continuing the treatment process, the platform will engage the patients because of the features that we have included in the platform, such as the quantitative feedbacks, the graphical, the tables, and the actually the numbers that we are giving the patients after performance of the rehab task. And although the platform is designed for the patients of stroke discharge from the hospital, however, it can be used by the people or patients with the hand injuries due to the farm work or an accident, the prosthetics, and burned hands. In the platform that we have developed, the KPIs are defined, actually have been defined by a team of engineers and statistics. For sure, we require some feedback from the experts and clinicians in authorized center, which is the future step of actually our project to collaborate with the clinicians and rehab experts in Riverview, actually health center, to get their receive their feedbacks about the KPIs. Based on the feedback that we need, we are open to add new KPIs and tasks to the actually platform and update our database to cover a wide range of upper limb rehab practice. And this, as I mentioned, the platform features that we have developed either for the mobile application or for the desktop application of the care provider, they need to be reviewed by the experts, and we would be happy if we are contacted for the collaboration to receiving the feedback from the experts. You can reach us at rtlab.ca and tactilerobotics.ca. Thank you again for taking time to listen to my presentation. I would be happy to answer your questions, if any.
Thanks so much, Ali. So we open the floor for some, the chat box for some questions, if any.
Sure.
Ali, I'm thinking of one of the possible scenarios due to COVID-19. I'm thinking of the scenario of training physiotherapy students with such device. Do you think that the requirements will be that different from one-to-one training? Like now you are explaining one therapist and one patient, right? But if we switch to a format of one main user who is the professor of group of instructor, and then many students, does the requirements will change, or and are you able to develop that such solution?
A very good question. Actually, as I mentioned, we are open to actually suggestion to add the for the new task, new actually KPIs to our database system. So even this platform can be used for teaching the actually rehab students, you know. So based on their actually the needs, if the professor and instructor has a plan, so we can actually receive their feedback, add the task or other features to the platform, and we are quite flexible about adding features to actually let this platform to be used in the educational sector as well.
Mm-hmm. So we have some questions here in the chat box. We have Archie Cooper asking if this has been trialed in rural or remote Manitoba.
Actually, not at this stage. We are in the development stage, and we are just trying this in a lab medium. Yep. So we have taken one setup at home and the other setup in the company, and so we are just trying to communicate remotely to make sure everything goes well. But in early future, we have the plan to use it in actually remote areas.
Trial it, okay. We have another question from Yumi Sakamoto from Computer Science Departments. She's asking if a lay person will be able to calibrate the smart glove prior to its use.
Actually, the smart we have a kind of I didn't explain actually in detail about the smart glove and the actually actuated part of the glove, because we have some kind of IPs and actually sensitive information on that, and we might want to file the patent on that. So, but we have the kind of self-initialization and auto-calibration procedure for the sensor. So even the layperson can use the device, but just actually pressing a button, and which is the actually power button, and use the smart gloves. There is no specific or difficult procedure for calibrating the sensor.
Then it looks like you have a first client. Archie is interested in trying this out in human determinants next year. So
sure. And I have received some questions.
That's encouraging. You can read the questions from me. So next question is from Katrina.
Mm-hmm.
Running this type of
I think this is the business plan that we are thinking out, and we are thinking of a kind of subscription actually plan to in case for example the patients wants to have access to the mobile apps, so they need to pay actually for that reasonable price and cost. That business part actually, the thing that the plan that we have is the kind of subscription actually fee that we charge the patients for that. If it can be a monthly or for a period of 6 months or 1 year, but to be honest, we have not decided about that part yet. So.
So we have next question from Archie Cooper. It's about the plug and plug capabilities, because she's worried about the remote areas of Manitoba. Can you elaborate on that, please?
About the rural is the issue.
Can I add a comment here?
Oh, hi, Yasra. How are you?
Hi, I'm good. How are you?
Yeah, sure. Please go ahead.
Sorry, before going to the next question, I think the main purpose of this question is to know how the government would deal with the clinicians, right? And I think this is some policy that the government, the federal or provincial government should adopt, actually considering our current situation. So we are going to maintain social distancing, staying at home. So this is something that should be negotiating, and this is not our responsibility to do. Once the technology is there, once we can prove that how safe it is and how we can help people actually to stay safer and have a qualitative and quantitative rehab session together, I think this is a good start to let the government know that there is a new window, the new opening in treatment. So they have to deal with that. The insurance should deal with that. This is something I think bigger than all of us here at Tactile Robotics, and this is something political that the clinician or the government should deal with later.
Thank you for addressing that.
You are, sorry?
I just said thank you for addressing that.
Oh, no problem. Thank you for asking.
I mean, with all due respect, government is certainly, they're a little parsimonious with the money right now. Feasibility and the economic impact or the economic benefit would have to be part of the study. And, it's early days yet, but I think you need to build that in because government's not going to jump to the pump on this one. Not a chance.
Yeah, absolutely. I totally agree with that. But the point is that this is the session that should be held for a patient. It could be remotely, it could be in the office. What I mean is that if we have a good technology to be used, this is something that we actually practice with dentistry. So our setup with dentistry, which is called Dentage, all the universities, the dentists, they like it very much. We started promotion, and at the first they had the same concerns that who is going to pay for that? But they saw that. So students, patients, all of them can actually work remotely, especially during such a pandemic, that this solution is working very well. So once we have a solution, once it works well, we can think about those parts. But without having the solution, the platform, and without showing how interesting and impressive it is, I think we cannot claim that, oh, we are going to design this, find a solution. No, you should design it, you should show it to us, we will find a solution.
Ali, can you explain the timeline for this solutions to be ready for trialing if people are interested in?
Yasser, can you help me about that? Because we need to consider different actually scenarios to make it complete. And the other thing is revealing the information, as I mentioned, regarding the design that we have for the robotic and haptics part.
Sure, yeah, absolutely. So this platform has 4 parts. One of them is the sensory system that we have already developed. Dr. Shuko has published the paper, I think, and he's working on other papers as well for validation part. Another part is the smart glove. We almost have it, like 90% of that is completed. The software programming part is working very well. We expect to have it ready to give it to Dr. Shuko's hand by the end of January, and the haptic sleeve by the end of March. So by the end of March, we would have a platform that is working remotely in a teleoperation mode, a bilateral teleoperation mode, and it has 4 features. So I would say in less than 4 months, we have the prototype of the system. And one thing, if I may, one thing I want to add. Ali just explained a white sensorized glove that is in the market, not completely in the market. I mean, it's ready to be commercialized. The price of that is $15,000 US, which is like 22K in Canadian. And in the field of rehab, I understand that this is a huge money. If you want to ask a patient to pay, even the rental plan, the leasing plan, if you want to have it, if you want to ask a patient to pay like $500 per week or 2 weeks, so that's a big money. The platform that we have and we are going to offer the patients, it's $4,000 US. And the marketing model, the sales model that we have, we are going to give it to the clinicians, and clinicians at a low price can actually rent it to the patients. So the price is something else that I wanted to discuss here. So in terms of price, the current company actually cannot beat us.
Ali, do you mind going back to the question by Archie Cooper? She's asking if, like how it works in remote areas when they don't have access to internet or simply Wi-Fi hasn't like enough bandwidth. You explained how it's plugged or unplugged. Can you please re-explain that in detail?
Yeah. Actually, this the tele-rehab platform requires the Wi-Fi connection for sure. So in case the Wi-Fi is not available, it's not possible to actually make a communication between the care provider and the patient.
Ali, you mean in real time, right?
Sorry?
In real time, you mean? But they can store the results and send it to the clinicians whenever
yes.
they have.
Yes.
Yeah.
Yeah. If there is no Wi-Fi, so I don't think we can actually find a place that doesn't support the Wi-Fi. But if the Wi-Fi is not great, yes, it depends actually upon the Wi-Fi speed, the internet speed, the ping rate, and if it is not high enough, so they can. It's a little bit difficult to have the live sessions and real-time communication, but it's possible for the patients to actually do the task and the data, or as I mentioned in the features, they can store the data in their cell phone, and at the later time, they can actually upload it to the database, and the care provider will be able to have access to the data in a later time. So there's another question about would a person be able to put the glove, take it off by themselves, or would they require assistance? Okay, we have actually talked a lot about the design of an easy to use a smart glove by the patients. If the one hand actually of the patient is healthy, so even when we were designing the gloves, we were trying to simulate the one hand as the actually impaired hand and one hand as the healthy one, and it's easy for the patient to actually just tighten the glove on the impaired hand. and they don't need help for that one. But in case both hands are impaired, for sure they will need an assistant for that.
Thank you, Ali. I see another question by Yumi Sakamoto. Your technology is very exciting, Ali. Thank you. Have you considered auditory feedback as well, or even gamifications, if the user can use your technology independently and repetitive movements are desirable?
Can you elaborate more a little bit about the question? What do you exactly mean by auditory feedback?
Yes, of course. Hi, Ali.
Hello.
So like I have worked on something similar to what you have actually created. And we have presented our results at the Augmented Humans, where Dr. Choku actually chaired. And we actually used auditory feedback, which I really liked. So for example, whenever our users or participants, we actually conducted an experiment, and then we asked participants to test our technology, and then there was an auditory feedback where they could actually hear nice sound whenever they did their movement properly. And then that's sort of motivated the users to actually work harder or make precise movement and stuff like that. And then your technology provides haptic feedback, right?
Right.
Yeah. And then I just wondered, if you would consider, adding some auditory feedback. So if something is not functioning, repetitively, if a user is failing, providing some feedback might actually guide them even better. I was wondering. Would you consider something like
very
that?
good question. Actually, we have not actually included this into the platform, but it's actually a feature, as I mentioned in the future, and I'm very thankful of you to mention that. We can add it as a feature because I explained a little bit about the actually switching a little bit from the qualitative feedback to the quantitative actually measures. So we have tried to show the progress using the numbers and graphs to the patients, but it's possible for us to actually add these kinds of auditory feedbacks to, as you mentioned, motivate the patients more for continuing the rehab practice.
That would be very exciting. Thank you.
Thank you too.
Thank you, Ali. Do we have any other questions by the audience? I don't see any. So Ali, I would invite you to maybe to send us the last message, last take-home message for the day, if you have any.
Actually, we are looking forward to receive the experts and actually experts in the rehab area about our platform to actually make it much stronger, as much as actually we can, to develop our database, and include many features, such as what Yumi mentioned, So we would be happy to have a kind of collaboration with the clinicians and experts to actually make our solution and platform unique.
Thank you very much. It was very, very exciting, very clear, and I really liked all the questions from the audience. You had even had some suggestions for improvements. So everything is okay, I think.
Yeah.
I would like to thank everyone here for listening and the interaction with our guest presenter, Dr. Ali Maddahi, from the College of Rehabilitation Science and Tactile Robotics. Thanks so much.
Thank you, everyone.
Thank you. Great presentation.
Thank you.
Great talk, Ali.